Welcome to everyone to this particular lecture, in the sense that in this lecture I will not discuss any specific physics content. Instead, I will rather spend a few minutes describing what I asked from different groups that belong to this audience of this group, of these lectures. In particular, these lectures and this course is offered to the students enrolled in the master program in physics at Trento University with the name of statistical field theory, but is simultaneously offered to the students enrolled to the quantitative and computational biology master program, still at the University in Trento with a different name, theoretical methods for soft matter. Now, the course is quite technical. And as I anticipated at the beginning of the course, at least a part of it is quite heavy on mathematics and on aspects of advanced quantum mechanics and stuff. So in the version of the course that I'm giving here, I am deliberately not touching too much on quantum mechanics, but starting from the lecture on Landau Approximation forward, I will be more heavy on math. It will be technically more involved. So I made the decision that this part may be a bit too cumbersome for students related to the quantitative and computational biology course program. So what I suggest is to split the course from this point on. I leave it as optional for the students of the QCB program only to do the following. They can A, continue with the program just as the physics students. If they like that and they feel they can do that, go ahead, you're more than welcome. B, they can instead go ahead and read two papers, which I have mentioned in the which I will mention now. One is Jarzynski paper on fluctuation theorem. That's reference 18 of the notes book. You can ask me privately if you can't find it, but if you look at the course notes, lecture notes, you'll find one of the references, and I believe it's reference 18, is on the Jarzynski paper on fluctuation theorem. You should be able to read it and understand it. It's not super easy, so take some time, and I think this will substitute a chapter that we are taking in field theory. And after you're done with that, you should pick up one paper in the literature where they use that formalism, Jarzynski rule, and tell me about it. Okay, so you should read Jarzynski formal paper, and then one paper that has used that equation for learning something about the biological system. So it's a bit of a project I'm leaving to you to look for it and complete the course with. So the idea would be that you've learned a sufficient amount of statistical mechanics to be able to understand that paper, and then you can use it for biophysics studies. You can understand biophysics studies that have relied on that paper. The Jarzynski formula basically tells you that you can force the system out of equilibrium, say, by pulling force, and by measuring the work you do by pulling out of equilibrium, say, a biopolymer, you can learn about the differences in free energy. And this has been experimentally explored quite a lot to learn about macromolecular biophysics. So let me repeat, for the quantitative and biology students, you can stop taking the course starting from the lecture on Landau theory on. I believe it's lecture 27. I don't have the right number. And you can do this project on Jarzynski, fluctuation theorem and applications. Or you can continue with the other students. For the physics students in the physics master degree, there's only option B. You're welcome to read Jarzynski paper, but it will not be part of the exam. The exam will be concerning Landau, Ginzburg, and Wilson renormalization group if I get that far. Okay? Thank you very much. And I will write another video like this on the exam later on.